In this video, we'll be learning how to calculate both the x-intercept and the y-intercept of a linear function by using algebra. So in order to find our x-intercept, we need to look for some patterns amongst the points that are along that x-axis. So we know that the x-intercept is found when we cross this blue line here, this x-axis. And if we take a look at all of the points on the x-axis, let's just plot a few. I'm just going to plot a couple here and then find their coordinates. So this one would be x is -4, y is 0. This is x is -2, y is 0. X is 1, y is 0. And x is 3, y is 0. So those are just a couple of points along the x-axis. And if you look at all of the points along the x-axis, which is where those x-intercepts point occurs, you'll notice that all of these points have a y value that is equal to 0. So we can use that to our advantage. We can say we know that the x-intercept occurs when we cross the x-axis, and here we can see that all of those x-axis points where an x-intercept could occur, they all have a y value that's equal to 0. So what we can do is, instead of trying to figure out what the point is by graphing the line, we can instead say, well, we know that x-intercepts occur when y is equal to 0, okay? So we know that we're going to have a coordinate point, and in that coordinate point, y is going to be 0. That is something that we know. And because of that, we can then use our equation to actually calculate that intercept point. So we're going to erase this now because we're going to actually find our actual intercept for this particular function. And here we're going to say, well, we have this function of 4x minus 3y equals 24. And we need to find the x-intercept. And the x-intercept occurs when y is equal to 0. So what we're going to do is we're going to go down to this function and we're going to say, well, we know that when the x-intercept occurs, y is equal to 0. So we're going to replace y with 0 and calculate the x value that matches up with it. So here we know that 3 times 0 is just 0. So we would have 4x minus 0 equals 24, but that's kind of silly. Why would you write minus 0? That's 0. So here we now really just have 4x equals 24. And we can solve for x then by dividing each side by 4. So essentially when y is equal to 0, we find that the x value that matches up with that is x equals 6. And so we can then take this value here, come all the way back up to the top, and say that our x-intercept occurs when x is 6 and y is 0. So we can go 1, 2, 3, 4, 5, 6 and plot it and say this is where our x-intercept occurs. Now, I know that we don't have a full line here right now, but we at least know one coordinate on that line, and we can use that to our advantage down the road. So now let's take a look at this same function and talk about how we would find the y-intercept for that particular function. So the y-intercept occurs when we cross the y-axis, which we can see is this red vertical line right here. So let's take a minute and again look at some coordinates that are along this y-axis where our y-intercept points are going to occur. So here, this is when x is 0, y is 3. X is, again, 0, y is 1, x is 0, y is -2, and x is 0, y is -4. And if you look at all of these points along the y-axis where the y-intercept is going to occur, you'll notice that they all have an x value that is equal to 0. And so again, just like with the x-intercept, we can now use this to our advantage with the y-intercept. And we can say, well, the y-intercept, which has to occur on this y-axis red line, all of those points have an x value that is equal to 0. So we know that in this coordinate point where this y-intercept occurs, there is an x value that is equal to 0. The x value is equal to 0, and we need to find y. And so we're going to take that same function. We have 4x minus 3y equals 24. And in order to find our y-intercept, we're going to replace x with 0. So we have 4 times 0 minus 3y equals 24. Well, 4 times 0 is just 0. So that's going to be 0 minus 3y equals 24. And leaving the 0 in there is a little silly. So this is just a -3y equals 24, and if we divide by that -3, we find that y is equal to -8. And what that tells us is that when x is 0, the y value that pairs with it is -8. So we could then graph this point on our y-axis, and we would know that that is where this linear function crosses the y-axis. So now let's dive in and look at some examples where we're going to calculate both intercepts for a couple of different functions. So here we can see that our function is -10x plus 5y equals 40. And we want to find the x and the y-intercept for that function. So we have to pick what we want to start with first. And I'm going to start with the x-intercept. And so I have to remember what's happening at all of those points on the x-intercept. So I know that the x-intercept is going to be a point. So I'm going to put the coordinate right here. And what I know about the x-intercept point is I know that this occurs when y equals 0. So I can actually place that into my coordinate right off the bat. And so we know that y equals 0 and that we need to find x. And that's kind of what I tell myself every time I'm looking for an intercept. If I'm finding the x-intercept, I'm going to be finding an x value, and I know that y is going to be 0. So I set y equal to 0, and then I find the x value that goes along with it. So here I can now take my original functions, -10x plus 5y, and instead of y, I'm going to write 0 because we're substituting 0 in there, and we're going to find x in order to find our x-intercept. Now I know that 5 times 0 is just 0, so I really have -10x is equal to 40. I divide by -10, and I find that x is equal to -4. So I can then take this value and I can plug it back in to the coordinate that I wrote at the very beginning. I know that my x-intercept point is going to be when x is -4, y is equal to 0. Now if I switch gears and I'm going to find the y-intercept point next, again, I know that this y-intercept is a point. But this time around, what I know about the y-intercept point is I know that all of the points along the y-axis have an x value equal to 0, and I need to find y. So again, an easy way to remember what you need to do is you think, well, it's the y-intercept, so I need to find y, and I know that x is equal to 0. So we can now take that original function, and this time we're going to replace x with 0, and we're going to leave the y in and solve for the y value. So -10 times 0 is just 0, so we simply have 5y is equal to 40. We can divide by 5, and we find that y is equal to 8. So again, we can take this, we can plug it in here, and we know that the y-intercept occurs when x is 0 and y is 8. So here in green, I now have both of my coordinates. My x-intercept is -4, 0, and my y-intercept is 0, 8. So let's take a look at a similar but slightly different example. So here we're going to go through that same process of finding x and y-intercepts, but I want you to note that the function is written a little bit differently. It doesn't really change the process all that much. It's still we're going to plug in a 0 and find a variable, but the solving process might look a little different because the equation is written a little bit differently. So again, let's start with our x-intercept over here. And remember, our x-intercept is going to be a coordinate point. And what we know about that coordinate point is we know that y is equal to 0 and that we need to find our x value in order to find our x-intercept. So we know y is equal to 0. And so what we're going to do is we're going to take this original function, and where the y is, we're going to replace it with 0. So here we have 0 equals 6x minus 18. And while this might look a little bit tricky to solve, it's not. Our goal in solving equations is always to get the variable by itself. So we need to start by moving the 18. So we add 18 to each side. We get 18 is equal to 6x. We divide by 6, and x is equal to 3. And so we can take that 3 and plug it in up here, and we know that our x-coordinate here is x is 3, and our x-intercept occurs when x is 3 and y is 0. All right, let's flip gears here. We're going to do the y-intercept point instead. So here we again know that this is a coordinate point. So I'm going to do that coordinate point in green. But with the y-intercept, we know that we're going to find y and that x is 0. So remember, y-intercept, we find y, and we know that the x value is 0. So again, we're going to take this equation and we're going to replace x with 0. So we have y equals 6 times 0 minus 18. Well, we know that 6 times 0 is just 0, and that 0 minus 18 leaves us with a y value equal to negative 18. And that's all we need to do in order to find our y-intercept when it's written in this way. So we know that when x is 0, y is negative 18. And here again, we were able to calculate our two intercept points.